Hello Chem 1A, this is Chapter 1, Lecture Video 5, and we're going to be continuing our discussion of units, starting with temperature scales. There are 3 different temperature scales out there as a major thing. Now, the 3 that we commonly see are Fahrenheit, Celsius, and Kelvin. Chemistry pretty much ignores Fahrenheit entirely. Again, that's a standard or imperial temperature unit. Most first world countries don't use Fahrenheit as their major temperature unit, but the US does. So yeah. So science pretty much doesn't use Fahrenheit at all. Celsius is much more preferable because it's scaled to water, being that 0 degrees Celsius is the freezing point of water and 100 degrees Celsius is the boiling point of water. It makes it easier to deal with in terms of the chemistry stuff. Now, we do need to be able to convert between any one of these unit systems. So the Fahrenheit to Celsius conversion is that Celsius temperature is equal to whatever your Fahrenheit temperature is, minus 32 times 5/9. And you can just rearrange this equation to get the other way, the reverse. To go from Celsius to Kelvin, it's a lot easier. We simply just take our temperature in Celsius and we add 273.15 to get our temperature in Kelvin. Now, you need to have this number memorized. I will not provide that on the test. However, I will provide this equation on the exam. So you don't need to memorize this Fahrenheit to Celsius conversion. You do, however, need to memorize how to convert between Celsius and Kelvin, as we do it kind of a lot. Now going from Kelvin to Celsius, we just do the opposite. We subtract 273.15. So let's do some examples of this. So if I want to go from negative 23 degrees Celsius to Fahrenheit, I just need to apply my equation there that I had on the previous slide. I know that my temperature in Celsius is equal to my temperature in Fahrenheit minus 32 times 5/9. Now, I know that I have negative 23 degrees Celsius here is equal to all that, Fahrenheit minus 32 times 5/9. So I need to multiply both sides by 9/5. These will cancel out, and I will get negative 41.4 degrees. Well, I guess technically we're out of Celsius now, but whatever. This is then equal to Fahrenheit minus 32. We need to add 32 to both sides. And this will give me a temperature of 9.4 degrees Fahrenheit. So there's my answer. As you can see, negative 9.4. Doing this is just the opposite. You can still apply that equation. I'm not going to do this one out for you guys. Please practice it on your own. You should get to 112 degrees Celsius if you have 234 degrees Fahrenheit. Now, changing from Celsius to Kelvin, that's a much easier beast, right? So I can just take my 12.000 degrees Celsius, add 273.15 Kelvin. This will get me 295.15 Kelvin as my answer here. There's like 285. I can add in my head, I swear. So there's that. Let's do one more, and then we'll call it for temperature scales. We have 36.00 Kelvin. We need to subtract 273.15 Kelvin to get Celsius. So this gives us negative 237.15 degrees Celsius. All right, so if you guys have any questions, as always, please contact me. Let's talk about density. Density is defined as the mass of an object divided by its volume. It's kind of a concentration unit of mass, right? How concentrated is the mass in your substance? We use density primarily to convert between mass and volume for an object. If I know an object's density and I know its mass, then I can calculate its volume. If I know an object's density and I know its volume, I can calculate its mass using primarily this equation. All right, so let's do an example of a density problem. This is an image or video image from Indiana Jones Raiders of the Lost Ark, and it's one of my favorite movies. If you've seen this movie before, you know that Indiana Jones, Harrison Ford's character in this case, is going to try to switch this golden statue here with this bag of sand there. He's doing this because this little plate here is a trap, and it's a pressure-based trap. The mass on top of that plate is triggered so that if it changes mass, the plate will descend, go down like that, and a giant boulder will roll after Indiana Jones as he tries to run away. Now, if you haven't seen the movie, you should definitely watch it. Spoiler alert, he tries to switch the bag of sand with the golden object, and the trap triggers. And I like to think if Indiana Jones had bothered to take a little chemistry, he would know that that had to be the case. Gold is an exceptionally dense metal with a density of 19.32 grams per milliliter, whereas sand is relatively very not dense. I mean, as far as solids go, sand has a density of about 2.65 grams per milliliter, which is much, much less than gold. And what he's trying to do is he's trying to compare the volume of this bag to the volume of the golden idol. And they look approximately close in volume, but they are much different in mass. And that is the thing that the trap is concerned with. So let's see how much volume of sand Indiana would needed to have put down on the plate in order so that the mass would be the same as the golden statue, and therefore the trap would not trigger. So if we're doing this calculation, the first thing we need to do is we need to figure out what mass of gold is present. Now I'm going to approximate the volume of that statue to about 1.5 liters. I need to convert this from 1 liter to milliliters, right? So 1.5 liters times 1,000 milliliters. This will give me 1,500 milliliters. Once I have this 1,500 milliliters, I can convert that using the density of gold here as a conversion factor. I know that 1 milliliter of gold is 19.32 grams of gold. And so by multiplying these out, you can see that my milliliters here cancel, and I'm left with grams of gold. What I get is that this statue has about 28,980 grams of gold in it. It's a very valuable statue. Now, if this trap is to not be triggered, then the mass of gold needs to be equal to the mass of sand that we replace it with, right? So if I replace the gold, I need to replace it with an equal mass of sand. In other words, this means that I need 28,980 grams of sand. And 1.5 liters does not make that much sand based off this density. So let's figure out what volume of sand that would be, right? So I have that 28,980 grams of sand, and I can use the density again as a conversion factor. I'm going to put grams down here, milliliters up here. 1 milliliter is 2.65 grams of sand. And again, we can see that grams here are going to cancel. We're going to be left with milliliters. Now, I'm then going to convert this from 1,000 milliliters in 1 liter because this is going to be a big number. All right, so let's do that calculation. You should get that our volume of sand required is approximately 11 liters of sand. Now, if you think about a 2-liter bottle for soda, multiply that by almost 6, and that's the size of sand bag that you would need to replace the golden statue so that the trap does not trigger. In other words, your bag of sand would look something like that instead of this tiny little bag that we have here. So hopefully this gives you an idea of movie magic. It actually, in this case, this is one of the times the movie's got it right. He tries to switch the stuff. It doesn't work. The boulder triggers the trap. He has to run away. Great movie. If you've never seen it, go watch it. All right. As always, if you have any questions, please come talk to me in my Zoom office hours or email me.